Mechanical tissues provide the strength and structural integrity of plants. These supporting or reinforcing elements constitute the plant's framework, support the crown, and provide resistance to breaking and bending. Mechanical tissues are most developed in the axial part of the shoot, the plant stem. They are characterized by the thickening of cell walls. Primary and secondary mechanical tissues differ in cell wall thickness, chemical composition of the walls, origin, and their position within the organs. In the youngest growing parts of plant organs, mechanical tissues are absent. The shape of these areas is maintained through high turgor pressure and the elastic membranes of the cells. Specialized mechanical tissues appear as the organs develop. There are two main types of mechanical tissue, cholenchyma and sclerenchyma, including sclerates. In the process of plant development, cholenchyma is the first to form. This is a supporting tissue consisting of elongated living cells with unevenly thickened, non-lignified walls. Cholenchyma serves to strengthen young, growing organs. Its cells stretch easily and practically do not hinder the elongation of the plant part in which they are located. Typically, cholenchyma is found in separate strands or as a continuous cylinder under the epidermis of the stem and leaf petials. And it also borders the veins in the leaves of dicotyledonous plants. Depending on the nature of thickenings, cholenchyma is classified as angular, thickened at the cell corners, lamellar, uniformly thickened in layers, or lacunar, loose with intercellular spaces. Primary and later secondary sclerenchyma develops later. It consists of elongated cells with uniformly thickened, often lignified walls, the contents of which die off at early stages. Sclerenchyma cell walls possess high strength, approaching that of steel. This tissue is widely present in the vegetative organs of land plants and constitutes the axial support. Young sclerenchyma cell walls consist of cellulose. Later, they may become impregnated with lignin and turn woody. There are two types of sclerenchyma cells: fibers and sclerates. Fibers are long, thin cells usually gathered into strands or bundles. Fibers that are part of the phloem, which conducts organic substances, are called bast fibers, while those located between the vessels of the water-conducting tissues are called wood fibers. Fiber walls are very thick, and the cell cavity is narrow, no more than 160 micrometers. The length of bast fibers can reach 10-40 mm in flax, 80 mm in nettle, and up to 500 mm in Chinese nettle or rami. The best fibers of flax and linden bark do not lignify and remain cellulosic, thereby retaining their elasticity. Sclerates are rounded or branched, dead cells with very thick lignified walls. They occur in groups or individually. They form the seed coat, nutshells, and the pits of cherries, plums, and apricots. They also give the pulp of pears its characteristic gritty texture. As fruits ripen, the sclerates in the pulp dissolve under the action of enzymes. Sclerates are also found in the leaves of many sclerophyllous plants, such as camellia, and even in stems such as those of the cinchona tree.